So guys, the last video we got our program to the point where the ball and the foot are moving the way they're supposed to for the game. Now it's time to adapt our game engine and our game a little bit to add in various game screens. So right now we're just starting playing the game right away. Typically when you have a video game of any kind, you have at least kind of like a main menu screen, lets you choose when you want to start playing, and then you have a screen where you're playing the game, and after the game you have a screen where it's like a game over screen. If I have drawn a little mock-up of that, let me just pull that up here. So this is sort of the typical setup. We have like a main menu screen. When I press start the game, I'll switch to a screen where I'm playing the game, and I play the game until I lose, and that brings up the game over screen. And in some old school game over screens, there might be like a retry and a quit button, where a retry takes you right back to the game and quit takes you back to the main menu. That might be like, oh, if you're playing Super Mario Brothers, you could retry the level you were on, and if you hit quit, it takes you to the main menu and you start all the way from the beginning again. So to design this, we're going to take advantage of a pattern in object-oriented design called a finite state machine. Patterns in object-oriented design are problems that come up quite often in design, have been very well studied, and somebody has decided here's a very good way to solve this sort of a problem. So the pattern that we're going to follow here, the finite state machine, is a good design pattern when you basically have a program that you want to run in one of a finite or a set number of different states. In this case, we're going to have three. We're going to have a main screen, we're going to have a playing screen, we're going to have a game over screen. And we want to be able to switch between those different states for this game, kind of following the arrows. In object-oriented design, how we would have to set this up, we need to think about, okay, how do we define a state? What makes a state for us in this setup? A state is a game screen or a scene for the program. And we want to have three different scenes that we can switch to in a very orderly fashion. Right? So a game screen for us is really mostly about the scene. So we're going to define a state to be a game screen which holds a scene and has a couple of different methods. The constructor for the game screen. We're going to use the initialize scene method to do all the setup of the scene so that we can put it on screen. Get scene so that we can put any particular screen onto the stage so we can see it. And then we'll add a start and a stop method where we can call the start method every time that this screen is put onto the stage, and we can call the stop method every time that this particular screen is taken off of the stage. Now, all scenes have those things in common. Some scenes would have more in their coding. For example, the gameplay screen will need to have all the logic to actually play our game. The main menu screen will just need to have the logic for the main menu, and the game over screen will just need to have the logic for the game over screen. Right, so we'll add that as we go by creating particular child classes of the game screen class. So let's take a look in code what that's going to look like. In this case, I'm going to just sort of show you all the code on screen all at once. There's not really too much to the abstract game screen class. I say it's abstract because we are not defining the code for each particular screen here in this abstract class. So if you want, you can pause the video here and just get a copy of this code, or you could get the code off of the course website. I'll put it there as well. But basically, a game screen in our engine just is a class which stores a scene, when we create a game screen, the scene is created by calling the initialize scene method. And in this class, initialize scene is an abstract method. Remember, that means that any child class that we create of GameScreen must supply the code for initialize scene so that the scene can get set up the way you want it to behave for that particular type of game screen. I'll show that code to you for a couple different game screens in the next video. Right, and then very simple other methods. We have a simple method just to return the scene. Again, we'll be using that to put it on stage. And we have two other methods which may or may not be overridden by the child classes. Right? They're not declared as abstract, so they don't have to be provided by the child classes. But I could override start in order to give commands what's to be done when I switch to that scene, and I could override stop to give commands what's to be done when I switch away from that scene. Now we'll be creating 3 different types of screen, and in our program we're going to need a way to manage which screen is on stage at a time. So the other class that we're going to add to our GameEngine code here is a screen manager. I'm going to pull that up on screen as well. The screen manager takes care of storing references to all the different types of game screens that we're going to create for our program, and managing which one is on screen at any particular time. Okay, I'm going to not go through writing all this code with you. I will have it on screen here. You can pause to copy the code, or you can get it off of the course website. But I'd like to run through a few ideas that the screen manager also uses from object-oriented design. The screen manager is referred to as a singleton class. A singleton class is a special kind of class where you ever only want to be able to declare one object of the singleton type. And if you declare any other objects of the singleton type, you really just get a reference to the same one. There's never more than one screen manager, no matter how many times I try to make a reference to the screen manager in the game. How do I handle that? How do I make it so that you can only ever make one instance of the screen manager? Well, the first thing is I make the constructor for screen manager private. I do have a constructor, and the constructor requires a stage parameter so that I can know what stage this particular screen manager is setting the scenes for. So I do have a constructor, but it's private. That means other classes can't call it. Well, if other classes can't call the constructor, how do they get screen managers to use? We're going to have a static method called initialize, which will set up a screen manager. When I call initialize, I'm going to need to pass a stage. And if there hasn't been an instance of the screen manager created yet, if instance is equal to null, then we'll make a new screen manager. But if there has been an instance already created, if I'm trying to initialize for the second time, nothing will happen. We will not create a new screen manager over top of the instance that we already have. This way I'm making sure that I only ever make one screen manager, only one ever gets initialized. But how can I get access to that screen manager to do things with it? Again, I'm going to have another public static method. Remember, static means kind of belongs to the class. So I'll be able to put the class name, capital S, screen manager, and I'll be able to put .getInstance to refer to the running instance of any screen manager. And then I can put a dot after that and do things that I want to do with it. Or I could even save a reference to it, but I can only get a reference to the one and only initialized screen manager that's running. So that's called the singleton design pattern. And with a screen manager, what can I do? I need to be able to add different screens to be able to place different screens that I can see on in during the game whenever I might see them. And I might want to be able to remove screens. So how do I save this list of screens? Well, I'm using a hash map to save the list of screens. And this part of the hash map is particularly interesting. Remember, a hash map kind of lines up one object with another object. So I could do something really simple here, like use a string and say I want to link a particular string to a particular game screen. So then I could have the string say main menu and link that to the main menu screen, and a string that says play and link that to the play screen. But instead of using a string or something simplistic like that, what we're using here is actually saying the name of the class that is being used to save the object for each type of screen. So eventually we're going to create a class for main menu screens, and we're going to create a class for play screens. And what this hash map is saying is, if you say you want the main menu class, I will provide you with the object that is the game screen for main menus. And if you say you want the gameplay screen class, I will provide you with the object that is the gameplay screen. And I think that's kind of a neat way to store the different screens that we're going to have. So when I add a screen, I'm just going to go to that hash map and say put in whatever class of screen you just gave me to add and the object. Right? If I want to remove a particular type of screen, all I have to do is say remove whatever class of screen you just told me to remove. The last thing that the screen manager needs to be able to do is set what scene is on stage at any particular time, or be able to change what screen is on stage at a given time. So in order to be able to do that, we are saving what is the current screen that is being displayed on stage at a given time. And then we're adding a method that says public void set screen. And we're just going to ask for the name of the class that you want to bring up on stage. Also note in here that I'm adding in this message throws an exception. If you try to put a screen on stage that has not been registered with the class and is null, it won't work. And I basically want that to give an error. I want that to throw an exception in the code and give the whole printout, null pointer at line, whatever line where I tried to do the code that didn't work. So then if I have a bug in my program, I'll have some traceable evidence to find where that bug is. So take a look at how the throws exception works in this method. How do we put a particular class of screen onto the stage? So you're telling me in the parameter what class of screen you want to see on stage. And the first thing I'm going to do is look into my hash map of game screens and see if I have a registered screen of that class. And if I do, I will get a game screen object, which I'm saving in the variable new screen, to go putting on stage. Now the result of this line should be that I have the game screen object for what screen you want to come up, if it's the main menu, the play screen, or the game over screen. But if you asked for something that's not registered yet, I could wind up getting a null return. Null meaning there's no value for that new screen. And if that happens, then I basically want to throw an error. That's not working properly. The game can't go forward if that happens. And so that's when I'm going to throw a new exception, and I can give a string to say what the problem is. So if you try to run a class that isn't registered, you're going to see the error message, screen not registered. It's just not going to work. And the program will crash at that point. Obviously, you want to write your code for the game in such a way that that's never going to happen. But as you're developing, if you get that message, you'll kind of have an idea as to why you're getting that message. Okay, now assuming we did not get a null screen, we actually have a screen to put up onto the stage, then what happens is the current screen has its stop method called. Remember that every screen has a start method for when it gets put on display and a stop method for when it gets taken down. So we're taking a screen down here. We're going to call it stop method if there is a current screen. We're going to call it stop method. And then we're going to set the current screen to be the one that you just asked to be displayed on screen. And then we're going to call the start method for that screen so that you can do any setup that needs to be done just prior to that screen being put on stage. And then this is why we needed the reference to the stage, so that we can set the scene to be whatever the current screen is and get the scene from the current screen. And that will allow us to switch between and manage as many different scenes as we want for our game. Okay, in the next video, sorry, still recovering from this cough. In the next video, we're going to see how to make those game screens.